Hi guys, it's Professor Stevens. We're going to keep moving. If you haven't seen my previous videos going over the different methods, there's 3 basic methods for solving logarithmic and exponential equations, and then also the properties. There was a video on that. There was videos showing how to convert between exponential and logarithms, and remember that they are inversely related, and you need to understand that relationship in order to understand the process of inversion and conversion, 2 different methods that work for certain types of problems. Also, you want to know the change of base formula, which is going to be referred to in this video, which is taking a log of some base is equal to doing the log of some other base of A over the log of that other base, base B. So we're going to use that. Again, if this seems like a lot of information that you're not familiar with, you definitely want to go back and look at those videos before watching this video. Alright, so let's take a look at part A here. And part A looks to me like it would be great for inversion because the inverse of an exponent is log. So I can take the natural log base e, same base as the base of my exponent, and that will undo the exponentiation. And that I want to do because I need to get x down out of that exponent position in order to be able to solve for it. So I'm trying to get this to break out of jail in a sense. And it really looks like he's in jail with that absolute values around it, but he's in jail not because of the absolute value, but because he's up in the exponent position. So we're going to break him out by doing inverse on each side. So we're going to take the natural log, which is log base e, of both sides. And then I'm just going to rewrite the entire expression on each side, e to the absolute value of x and 50. And the reason that this works is because now I can use the exponent property of logarithms to move the exponent in front of the logarithm. And then this cancels to 1, also using properties of logs. So my left-hand side has become nice and simple. This is already simple. And I like to put parentheses, but just so you know, even if you don't have parentheses, unless it's a quantity with pluses and minuses, with terms such as this, like the log of x minus 1, you need parentheses in that case. But if it's just a single term, you don't need these parentheses, but I like them. But this, you can actually just write it like this. Alright, so now that I have that, remember with absolute value, it's a distance from 0. So the distance from 0 can be plus or minus natural log of 50. And if I use my calculator or Excel to evaluate that, I will get the solution set plus and minus 3.912, rounded to the nearest thousandth. And I'm doing that because that was the directions here. Sometimes they'll ask you to leave it in exact form, and this would be the exact form right here. So you got to pay attention to how they want the final answer. In this one, they wanted us to approximate. Alright, so let's go on to this other example here, which is similar, but it has an extra step because we're going to have to do some simplifying first. I want to create a single exponential expression, so I can use the properties of exponents. Remember, if you have 2 exponential expressions with the same base, you can add those together. So when I add them, I have e to the power of 4x plus x is 5x, and then the minus 1. So now I have a single exponential expression on one side, and at this point I can take the natural log of both sides. So I'm going to do that again, where I take the natural log. It's getting a little crowded here, but we can make it. So I have e to the power of 5x plus 1 there, and 5e here. And then I'll move my exponent in front, and also the natural log of e simplifies to 1. So in effect, it's like taking the log of an exponent, use the same base log. In a way, it cancels it. We're not supposed to really say that it cancels, but in effect, that's what happens. And so now we have the natural log of 5 plus the natural log of e. So why did I do that? Because this is a product, and I wanted to simplify this to 1. I don't know if that really helps me very much, but yeah, maybe it doesn't help me very much. I'm going to leave it as 5e, natural log of 5e. Sometimes it'll help to do that, and sometimes it won't. So in this case, I think I'll just leave it as is. And then I'm going to solve for x, so I subtract 1 from each side. Again, you can or you don't need to put parentheses if it's a single term, but I feel safer doing it, so I tend to do it. And then divide by 5 on both sides. So now my exact answer is natural log of 5e minus 1 quantity divided by 5. So I have to evaluate that using my calculator to get the answer, which is 7.222. And you really want to always be checking your answers to make sure, especially if it's a logarithm, because if there's a logarithm, there's a restriction on the domain. Remember, the domain has to be only x values that are positive, greater than 0. So you got to be real careful if you're dealing with a logarithmic. But with the exponents, it's not as much of a situation because there's no restriction on x for exponents. Exponential equations or functions, there's no problem there for that, but you should want to check it anyways, just so that you can be confident that you have the right answer and maybe catch your mistakes before it's too late. All right, so we'll go on and do another one. Let's do, we can look at example 4 maybe. Now remember, the publisher does these examples also, and I'm taking similar examples. Wait, let's see. I think I actually have it already written down in this. Let's see. Go back one. So what I'm trying to say is that the publisher did a very similar one to this in the textbook and in video format. So if you want extra fortifying and you want to see it again from a different perspective, you might want to look at that video. All right, so for this one, it's very special. It says it's quadratic in form. Would you have noticed that on your own? Because you want to get into the habit of being able to tell. Now, a giveaway is that it's 3 terms. So usually with these problems in this section, if you see 3 terms, it's probably going to be quadratic in form. And then if you see a 2 on your exponent, or even any even number where a 2 can be factored out, that's another sign that it could be quadratic in form. And even better when you see that this exponent is the double of this exponent, right? So this is looking really like an exponent, it really looks like a quadratic to me, even without being told that it's quadratic in form. So I see this and I think, okay, that's e to the 2x, which I can also write as e to the x times 2, or to the power of 2. And then I have e to the x right there next to the 6. So this, if I let u equal e to the x, then I can rewrite this as u squared minus 6u plus 5 equals 0. And then it's a quadratic that I'm accustomed to solving with either x equals negative b plus or minus the square root of b squared minus 4ac. And maybe you have, right, the quadratic form. Maybe you have this programmed in your Excel spreadsheet, or you know how to program it real quick. So you might be able to solve this fairly quickly, or maybe it'll even work with factoring. So we can try to factor it and see. Let's see, to get 5, I could do 1 and 5. It has to be the same sign, so I get a positive there, and this is minus, so negative, negative. And then you can double check that, but I know it's correct. So then u is equal to 1, or u is equal to 5. Now that's just u, though. That would not be my answer. So the danger of using u substitution is this, right? That would not be the answer, because remember, u is a placeholder for this expression. So actually you have to do one more step. You have to back substitute. You have to do e to the x equals 1 or e to the x equals 5. And now you've got to get that x down out of the exponent again. So let's use inversion. Let's take the natural log of both sides. So what happens when we do that? We're doing it everywhere. Is it cancels out the e, so then x drops down, Okay, and what can you raise to the power of, or what, let me try to, if I rewrite this in exponential form, that would be the natural log, which is base e, of x equals 1. So e to what power equals 1 is the question. Any base to the power of 0 equals 1. And if you didn't, you shouldn't really actually have to think about that if you know your properties, because it's one of the things that we are supposed to have sort of memorized because we see it so often, or because it makes sense. It's just one of those things that you're supposed to know to make your life easier. So you don't have to go over to the calculator and use the natural log of 1. It can make things move a lot faster and more smoothly for you. All right, and then on this side we get x equals the natural log of 5, and this one you would actually need a calculator for, and that turns out to be, well, let's see, did they want it in exact form? Okay, yeah, they want exact values, so we don't need to round on this, which is great because now I have my solution set 0 and natural log of 5. Okay, example 5, we have, actually I want to do more like that previous one, don't you think? Don't you think it would be good to do more examples like that? So let me pause here and open up another one. Alright, here's another one that's quadratic in form. Would you have been able to see it yourself? If you rewrite the first term as 5 to the power of x quantity squared, and you can do that because of the properties of exponents. And then you have this, and let's set it equal to 0. And now we can do u substitution. And then solve. Let's see if it factors. 28 you can do it with 7 and 3. Or I meant to say 4 and 3, 4 and 7. So 4 and 7. We have a negative here, so they have to be opposite signs, and the bigger number must be positive. So you can be 4 or negative 7. So then we back substitute. Make some room here for when I take the logs. Or 5 to the x equals negative 7. Right, and then we're taking the log of both sides. So I'm going to log base 5. So that'll bring my x down. And then I have log x equals, do we want exact or, let me see, oh, I didn't write the directions down. I got this out of the book. So the directions say express solutions in exact form. So for this, we're not even going to. If you were going to evaluate this, it would be log of 4 over log of 5, and that's base 10 when you don't write a base, or natural log of 4 over natural log of 5. Both of those would get you the approximate answer if you had to evaluate it. But the directions for this said to leave it in exact form, so that is my answer, log base 5 of 4. All right, oh, but I have this side over here to do as well. So taking the log base 5 of both sides, I get x equals log base 5 of negative 7. But this is a problem, domain error. You cannot have a negative input, because remember, we're raising to a power. So it's 5 to the power of something equals negative 7. How are you going to get that? How is that going to happen? You know? So we have to exclude, this is not possible. So this actually does turn out to be our final answer. Do you want to do another one like that? Could do one more? How about 3e to the 2x plus 2e to the x equals 1. So I'm going to let u equal e to the x again. So I have 3 times e to the x squared plus 2 times e to the x minus 1 equals 0. So that's 3u squared plus 2u minus 1 equals 0, where u is equal to e to the x. Then let's see if this factors 3u and u. So you can do trial and error. I've actually taught you in the past to do AC method, which I guess I'll demonstrate because I really do like it, even though it might be easy sometimes to just do trial and error if there's not a lot of options for, like, you've got a prime here and a prime here, so actually trial and error would probably be the easiest way to do it. But 3 times negative 1 is negative 3, so I need a factor pair that will give me a sum of positive 2. Okay, so product, sum. So I have negative 1 times 3 would give me a sum of 2. So I'm going to do 3u squared, negative 1. So I left the two end terms the same, and I'm going to expand this, rewrite it as a sum of negative, I'll do positive 3u and minus 1u. Then I can factor out common factors from each pairing. So I get 3u times u plus 1 minus 1. I can factor out a negative 1, u plus 1. Make sure your two factors match so you didn't make any mistakes. So then I can factor out that common factor. And then u is equal to negative 1 or 1/3. And then we have to back substitute. So we have, what was it again? E to the x, right? So e to the x can be equal to negative 1, or e to the x can be equal to 1/3. You take the natural log of both sides. Another thing you can do here is you can convert.